Hello everybody again, and in this part, in the last part of this lesson, we speak about Pythagorean triples and we see how they can be useful in real problems. First of all, let me remind you what they are. They are special triangles, actually the lengths of the sides of special right triangles, which are very easy to calculate. I advised that in the article, and I'll say that again, that I think that it is worthwhile to memorize only only this first line of the table, which I presented there. Those Pythagorean triples mean actually the following. If you have a triangle with legs 3 and 4, then the hypotenuse is 5. That's 4, that's 3, that's 5. The next one, if the smallest leg is 5, the biggest leg is 12, then the hypotenuse is 13. Also 8, 15, 17, and 7, 24, 25. The most common is this one, and remember that we can actually multiply it by any number. So we have a triangle with legs 6, 8, and then the hypotenuse is 10. If we have if we have multiplied by 3, then we get 9, 12, and 15. We can also multiply by 4, and then we have 12, and 16, and 20. That's it. So those are Pythagorean triples, and they're very useful in Olympiads, in fast, when you have to think fast. Let us have a look at this problem. It appeared in American Mathematical Competition 8, AMC 8, in 2017. I'd like to remind you that in that competition you have to answer 25 questions in 40 minutes. It means that for every question you have only 1 minute 36 seconds. It's obvious that you can do one question longer, one question faster. But in general, it's very, very, very tough time limit. So what do we have here? We have a quadrilateral ABCD, which is of this unusual form. But we also know that BCD is right. This angle is right, and this gives us all necessary information to start thinking. So we have AB 12, BC 4, CD 3, and AD 13. Already those 4 and 3 and 12 and 13, they somehow hint at Pythagorean triples, but to have Pythagorean triples, we have to have right triangles. We don't see any right triangles here. And actually to do that, I'll cut it again. To create right triangles, we have to draw something. The less we draw, the better. It's construction. But in this case, it is sufficient to draw only one line, only one segment, actually to connect D and B, points D and B. And you see what we get by doing this. Again, this one, this is the right angle. So what we have here is BC. Let us remind each other. BC is 4 and CD is 3. This one is 4, this one is 3. It immediately gives us that BD is 5. But if we look at AB, AD, AB is 12, AD is 13, which in turn gives us the fact that ABD is a right triangle. Actually, it needs to be proven, because you don't know if you have just 3 sides. But if you have a triangle with sides 5, 12, and 13, you can be sure that it's a right triangle. So this angle is also right. And then our problem is very simple. We have to calculate the area of ABD, which is SABD. It's 1/2 of the product of the legs. It's 5 times 12. And the smaller triangle, right triangle again, BCD, the area of BCD is 1/2 4 times 3. And the unknown area as x is actually SABD minus SBCD, which gives us, I can factor 1/2, and I see that this is 12. Actually, I can factor also 12. And then it's 5 minus 1. And that's 1/2, 12 by 4. And then it's 24. Of course, so our answer is, we actually mark this. This is our answer. But I was explaining this slowly, I hope methodically, but the gist is that you have to think fast. You had only 1 minute 36 seconds for that. And to do that, you have to memorize, you have to remember Pythagorean triples. And if you remember them, you see there are 2 triples which you have to know. That's 4, 3, 5 and 5, 12, 13. But if you remember them, it would take me 30 seconds to understand, to calculate on a piece of scratch paper. And there are other problems like that. And to tell you in the end that this is easy to memorize. Actually, they are remembered easily, especially 3, 4, 5, and the first 2. I sometimes forget this one, but looking at it now, I hope this video will help me to remember. So my advice is to memorize this line if you want to succeed at American mathematical competitions and elsewhere where you have to think fast. Thank you for watching. Until next time.